Today our new topic is on coastal littoral processes. The coastal formation that we mentioned earlier are a result of coastal littoral transport. The changes may be in the short term of hours or days, or in the mesoscale of weeks or months, or in the long term of years or decades. The shoreline variability in this case can be investigated based on historical satellite imagery and based on hydrographic survey, which can be carried out along the shoreline in transects like this, so that the coastline can be demarcated and the long-term changes are identified. This figure here shows long-time monitoring of a particular coastal area from as early as 1941 in approximately 10-year interval up to 1985. You can see that there is a predominant flow here, and this particular section of the coastline has evolved and grown. That is essentially a spit, and this spit has caused this flow to deflect and changes direction, so that instead of mainly flowing along this direction, it has now begin to flow in this direction, and eventually when this spit has grown to this side, the flow is now predominantly flowing here instead. But the process continues to evolve such that the spit seems to be eroded subsequently and is being cut off to leave a sandbar. Detailed bathymetry survey has reviewed the depth of the area, and so in this particular case it shows how the long-term observation is able to help us understand the coastal littoral process as well as the coastal formation. The stability of a section of shoreline depends on the balance between the volume of sediment available to that section and the net sediment transport due to onshore, offshore, and also the alongshore processes. Although the instantaneous position might undergo short-term changes such as erosion or accretion, a shoreline may be in the long term under dynamic equilibrium, meaning that the average shoreline position is relatively stable over time. For example, a shoreline may be experiencing erosion certain months of the year and accretion in other months of the year, but overall, year by year, it is relatively stable. To limit or reverse the shoreline erosion or accretion, coastal projects such as construction of structures, dredging, and beach tourism may be considered. However, these projects can upset the existing dynamic equilibrium of the adjacent shorelines, such that they lead to undesirable erosion or accretion if not properly designed, or they may lead to the development of a new equilibrium condition. This figure here shows Sultan Mahmud Airport in Terengganu, which was constructed such that the runway protrude into the sea, and so a headland was constructed in this relatively long straight section of the coastline. As a result of this headland, it has interfered with the local littoral transport. The northern shoreline was subsequently severely eroded, causing large extent of land to be lost to the sea. As a result of that, subsequent action was taken so that a series of groin was constructed in order to restore the beach near the coastal front of University Malaysia Terengganu. This example highlight how coastal projects, if not properly designed for, can interrupt with the existing dynamic and equilibrium of the coastal littoral process.